guys, today we are learning an important technique called algebraic substitution for solving indefinite integrals. Sometimes integration isn't straightforward and we need a smarter approach. In this situation, substitution helps by simplifying complex expressions into easier forms. By the end of this lesson, you will see how this trick turns tough problems into simple ones. Let's take some examples on this type of integrals. Example 1. Our first example says, evaluate integral of 10 on 5x minus 10 dx. When this problem is given to you, you need to go through some procedures to solve this problem. First of all, we need to choose a substitution from this. So in this situation, we need to identify a part of this function that when replaced with a new variable, let's say u, simplifies the integral. And usually, this is an inner part of the function or a term inside a power, roots, or even sometimes trigonometric functions. But in our case, if we will let the denominator here to be another variable u, we let u to be 5x minus 10. That's the first thing. Secondly, we have to differentiate the substitution. So we need to differentiate the u with respect to x. Then after that, we find the x. The u dx equals 5. Differential of a constant is 0. Now let's make the x the subject. The u equals 5 dx, and hence our dx equals the u on 5. The reason why we are doing this is to convert every variable here that is in x to another variable u. So at this particular point, we need to rewrite the integral in terms of u. We know that our integral of 10 on 5x minus 10 dx now becomes integral of 10 on the whole of it. We said it is what? So it means now this becomes u. And we were able to find the dx. Now the x is the u on 5. So we place that one to the u on 5. So now everything is in terms of u. Let's write it well. We're going to get this goes to this 2. So we are going to get integral of 2 on u du, of which we can factor the 2 out. So we are going to get 2 integral of 1 on u du. We learned from our previous video that anytime we integrate 1 on a particular variable, you get a ln of that particular variable. So here we are going to get 2 ln u, then our constant c. At this stage, we have to replace u with the original variable in the question to get our answer. In doing so, it means we are going to get 2 ln u is this 5x minus 10 plus c, and this becomes our answer. Let's take our second example on that. Example 2. Our second example also says evaluate integral of 2x by x squared plus 1 all cube dx. We are given integral of 2x x squared plus 1 cube dx. If you look at this critically, you can see that if we let this one to be u, it will make the expression very simple. So we say let u equals x squared plus 1. You have to differentiate u with respect to x. So it means our du becomes 2x dx. Make the x the subject. So our dx now becomes the u on 2x. Why are we doing so? Because we know that this 2x will cancel this 2x. That's why we chose this as our u, but not this. You also need to place math in whatever you choose. So rewriting the integral, we will get integral of 2x u cubed. Now our dx is this, the u on 2x, of which this cancels this. We now have u cubed du. We can integrate. Integrating this, we are going to get 1 on 4 u power what? 4 plus c. But our u was represented as x squared plus 1. So let's put that one back. So we are going to get 1 on 4 x squared plus 1 power 4 plus our constant of integration, and that is that. Third example. Third example also says evaluate integral of 1 on x plus 3 squared dx. Let our u to be x plus 3. So let u equals x plus 3. Differentiate with respect to x. The u equals dx. We make the x the subject. Already the x is the subject, so the x is equal to the u. We substitute back into the function. We know that our integral of 1 on x plus 3 squared dx becomes integral of 1 on, this is our u squared, and then our dx is now the u. Everything is now in terms of u. This one has a power over here, so we need to rewrite it well. U power negative 2 du. Integrating this, we add 1 to that, and that will give us u power negative 1 divided by negative 1, and that is negative 1 here, plus c, which is the same as negative 1 on our u was x plus 3, so x plus 3 plus c, and that's answer. Our fourth example says find the given integral of x root 2x squared plus 1 dx using a suitable change of variable only when necessary. So we have integral of x root 2x squared plus 1 dx. This we let u equals 2x squared plus 1, and of which our du equals 4x dx. Making the dx the subject, we are going to get the u on 4x. So let's substitute everything back. Integral of x root 2x squared plus 1 dx is now integral of x root, remember the whole of this is now u, so u, and then the x is now the u on 4x, of which you can see that this x cancels this x, and now we are going to have integral of root u du. This 4 we factorize, we are going to get 1 on 4, so we have 1 on 4 integral of u per half du, and integrating the u per half, we are getting 1 on 4 by, and when we add 1 to this, we will get 3 on 2, which when we spoke, we are going to get 2 on 3, u power 3 on 2 plus c. Simplifying this part, we have 1 on 6. Our u is 2x squared plus 1 power 3 on 2 plus c. You can go further to make it in the form of root, and that will give us 1 on 6 2x squared plus 1 square root of that cube plus c. And that's the answer. Our next problem, evaluate the integral of 3x 4x plus 1 dx. So we say let u equals 4x plus 1. The u becomes 4 dx, and our dx is now the u on 4. Over here, you can see that when we substitute u here and then dx as the u on 4, there will be still a variable x in integral function, and hence, in order to get rid of that x, we need to remake x the subject from here. So we say from u equals 4x plus 1, we are going to get u minus 1 equals 4x, of which our x becomes u minus 1 on 4. Now substituting, we have 3 by our x is now this u minus 1 on 4 root of u, and now the x is now the u on 4. The u on 4. Let's factorize all the constants out. At the numerator, we have 3. At the denominator, we have 4 by 4, and that's 16 out. So now our integrand is u minus 1 by u power half du, of which we can simplify, and that gives us u by u power half. We add the powers, and that will give us u power 3 on 2, and then this by this minus u power half du. So now we can integrate at this point. Integrating, we have our constant 3 on 16, and over here when we add 1 to 3 on 2, it gives us 5 on 2. So when we reciprocate here, we're going to get 2 on 5 u power 5 on 2 minus 2 on 3 u power 3 on 2 plus c. Multiplying through by that, we get 3 on 40 u power 5 on 2 minus 1 on 8 u power 3 on 2 plus c as our answer. And finally, we have integral of y on y plus 1 dy. So you say let u equals y plus 1, du equals dy, which means the y is equals to du. Substituting, it will be impossible for us to cancel this y, so you have to make y the subject from here. So from u equals y plus 1, our y becomes u minus 1, of which when we substitute everything back, y is now u minus 1, and then this is u, and over here this are the u. So at this stage we can split it. So we are going to get u on u minus 1 on u du, which will give us 1 minus 1 on u du. So when we integrate this, we are getting u minus ln u plus c, but u is y plus 1, y plus 1 plus c, and that's answer. Though this, we can have another method, that's a splitting method, to solve it directly, but because of we are looking at algebraic substitution, that's why I solve it this manner. Thank you very much for watching. Please subscribe, share and comment. Let your colleagues also get to know of this channel to motivate us to bring you more videos. Bye bye.